Question number 6 says, given quadrilateral plan whose diagonals PA and LN bisect each other, complete the statements. A. Triangle LEP is congruent to blank, and triangle LEA is congruent to blank, and explain. B. Angle ALE is congruent to blank, and angle ELP is congruent to blank. Explain. Explain how the information in Part B can be used to prove that quadrilateral plan is a parallelogram. And D. Complete the theorem. If the diagonals of a quadrilateral blank, then the quadrilateral is a blank. For this particular section, I'm going to give you 4 minutes to work through all of question number 6. Go ahead and pause your video now. I was able to prove that triangle LEP was congruent to triangle NEA, and triangle LEA is congruent to triangle NEP. I used the definition of bisect that told me that the two sides are congruent from the point of intersection to the outside edges. And I know that vertical angles are congruent by the vertical angle theorem. So I was able to prove that the triangles were all congruent to opposite pairs, because this would have been congruent. These would have been congruent. And I basically used side angle side. I was able to prove in part B that these angles are congruent to one another, PNE and ENA, and that was by corresponding parts of congruent triangles are congruent. So I said ALE, that's this angle, is congruent to PNE, and then I was able to say that ELP, this angle, was congruent to this angle by corresponding parts of congruent triangles congruent. And because I said that, these are actually alternate interior angles, which implies that my sides are parallel to one another. So I'm able to ultimately prove that this side is parallel to this side is parallel to this side, which by definition makes this a parallelogram. So if we go back to what we started with in this particular problem, we started with the diagonals bisecting each other. And if diagonals bisect each other, we can work out to prove that this is indeed a parallelogram. On to the next set of questions.